be with your Friday lesson. So we are continuing our topic of circuits, and we are now going to be building a parallel circuit. We will talk a little bit about what that looks like. I've also included a parallel circuit video explanation on your PowerPoint that you can access. It's a YouTube video, not me, but it's a different YouTube video explaining the concept. We'll do a little bit of review from our lesson on our last day, which was Wednesday, just reviewing some of those topics there. And then I will once again take you through some of the online tools, the circuit builder online, and we will build some of our parallel circuits together. So just as part of the review for this lesson, we're going to just quickly review a series circuit. If we remember from last time, if you've done that lesson, it's a circuit that only has one path for the electrons to flow down. So when we're doing this, it has one pathway to power multiple light bulbs, which is the easiest way to explain. It can power a bunch of different things, but it's only got one strand that it is able to follow. Doesn't have any other paths that it's able to go down. So what happens to the electrons in this type of circuit? Like we said, they only have one pathway that they can flow down. So they don't have alternate routes. They only have one way to go, and they have to take that way, and they power as many light bulbs as are on that path. Which leads us to our next question. What does the brightness of the light bulbs look like in a series circuit? We saw from our different examples in the last lesson that the light bulbs are the same brightness, but they're dimmer than if just one light bulb was lit up. So if we add more batteries, we're able to power those light bulbs more, but light bulb 1 and light bulb 2 are the same brightness. One is not brighter than the other. They are equal brightness. So as we move on, we're going to talk about parallel circuits. And so what is a parallel circuit? It'll go through it on the video for you here if you want to watch that. If not, very simply put, a parallel circuit provides two pathways for the electrons to pass down. They don't have to just take the one path. They have options. So it's kind of like a fork in the road where you can go left or you can go right. It has multiple pathways that the electrons can go down. So they're not restricted to just one route that they can take. They have two or more routes that they can take to get back to the main power source. So when we're building circuits today, we will be given a lot of the same materials that we have in previous classes. So you'll have access to that same website that you were able to use before. And so we're going to start by creating a series circuit with a switch, and we'll draw that. Part 2, we'll be using all 4 clips, and we will be eventually creating our parallel circuit. This will be available for you on Edmodo, so don't worry about that. I will do this more as a demonstration with the build. And then finally, there will be a take-home assessment. I will go into a little bit more detail on that later. Don't worry about this due date. Again, these PowerPoints are made for in-class, and obviously we are not in class. So just going on to the information that you will need. So just like on Wednesday, here are your instructions for creating your parallel circuit and the steps that you will take. You're going to start by creating a series circuit, just like we did on Wednesday. You're going to draw what that looks like, and then using all of the wires that you need, you will create another circuit that uses one battery and lets both light bulbs light up, and we will draw a diagram of that. Again, the instructions are repeated. You will have access to these. Now, just like last time, we have an example with a switch and without a switch. Again, you can do both. You can do one with or without the switch. It doesn't matter. They're the same experiment overall. Just one has a switch and one does not have a switch. If you do both, awesome. If you just choose to do one or the other, that's totally okay too. But the main part is this second half where the diagram of series circuit 1 and then the diagram of circuit number 2. Now, this will end up being a parallel circuit. But so what you're going to do is you're going to draw what you created in this box and in this box. And then down here, you're going to describe how you have set up the first circuit and then explain how you set up the second circuit. So in here, you're just going to explain, I created one pathway. I made sure that the light bulbs were on the same side. However you want to explain what you've created. So basically, you're describing your drawing. And then for this one, you're going to explain how you incorporated the other pathway into your drawing and how you chose to do that. So once again, we're going to have 2 light bulbs, 5 wires, a light bulb holder, battery and battery holder, and that's what we'll go through there. So in this is giving you an example. So if you're really stuck, you can use this as your example and try and recreate this on the website. But this is an example of a parallel circuit. So you've got your symbols, you've got your battery, your light bulb, and your wire. Again, notice that we only have one light bulb in this circuit. For our examples, we will be using two batteries. In this one, they only have the one. And it just gives you a definition of a parallel circuit. So a parallel circuit has two or more paths for a current to flow through. The voltage, which we haven't talked about yet, it talks about the amount of power. So the voltage or amount of power is the same across each component of the parallel circuit. So parallel wiring allows the electric current to move through different pathways. The current can flow to light 1 or light 2, but the power source is split equally. So you'll see the difference of what this looks like and how it's different than a parallel circuit, but we will go through that now. So this is your take-home assessment before I show you the setup for how we're going to do the experiment on the website. This is your take-home assessment. So this type of circuit is one of the types of circuits that we've talked about, either series or parallel. Not simple, it's series or parallel. Those are your two options. And then this one is the other option. So there's one of each. You have to determine which is which should be pretty easy considering you have an example of one right up here. So it should be able to, because this one looks exactly the same, so it should be pretty straightforward. But then you're going to explain as best as you can what the difference between the two of them are. So you may have to look back to what we talked about on Wednesday with a series circuit, but that's what you're doing on this page. And then that is all that you will have for here. So I'm just going to minimize this, and I'll scroll up to our expectations here. So I'll just get this out of the way for now. We'll get rid of this. And here again is our website. We've been using this a lot, so it's all the same. We are going to go to an intro. So if I click back here, it gives me my expectation. So I need two light bulbs, some wire, one light bulb holder. I think this is a typo. Anyway, but so I need two light bulbs for this diagram and then two batteries it has us using. So we'll get our two light bulbs here. And so here's what we're going to do. So we have to start by creating a series circuit. So what we will start by doing is we've got our two light bulbs here. I made it do a little flip. And then we've got our two batteries here. So if we just do a little connection there, a little connection here. For this one, I don't think I will use a switch. I'm just going to create the circuit as I see fit. Going to give myself a little bit more room there. Here, and here is a series circuit. So now this is the brightness, and again, the length of these lines represents how bright the light bulb is. So just to show you an example, if I cut this connection here, and I'll cut this one off too. So I just leave this one off. But if I show you the brightness of the light bulb with two batteries and just one light bulb to power, you can see how significantly brighter that light bulb is. But when I cut it and reconnect it to this other light bulb here, the brightness, oh, whoops. Cut there. That's right. That's because I have lost my connection there. So not all of my circles were colored in. That was the problem why there wasn't a connection there. So, but the brightness is significantly less when we have both of the batteries powering both of the light bulbs. So what it would like, that would be what I draw in this spot right here. So I would draw what I created over on this one. And then so a series circuit powers both of the light bulbs equally, but they are dimmer. They're not as bright as if one light was being powered by both light bulbs. So that's how I would describe my setup. I connected both wires are on the same plane, both batteries are right beside each other, and I would draw a picture of it. So now what it wants me to do, and I will scroll up here, so create a series circuit, draw what it looks like. So using all of the alligator wires, create another circuit that uses one battery and lets both light bulbs light up. So what I will do is I will go back here, and I am going to just cut some of these apart And so what I can do here actually is I can go and I can create a pathway like that, but I'll just cut this one for now. So what I can do though is I can have multiple wires entering in on this same point. So now you can see that they're both connected and it is a different pathway. So this is now one pathway lighting up, and I'm actually going to get rid of, because it does ask me to only use the one battery. So what I'm going to do is I'll cut that off here. So it does ask me to only use the one battery. So I'll just leave this off to the side for now. And then what I will do is here and here. And so here is my one pathway powering this one light bulb. But now I want to have the multiple pathways, and I'm just going to reset this actually. So then what we can see here. So we've got our one battery, and I'm actually going to set this one up similar to how they have this one set up. So you can see that they are on two different pathways, and that's what makes it a parallel circuit. So what I will do is I will have one light bulb here and one light bulb here, and I will now add in the wires. So I've got wire number 1 here, wire number 2 here, just to make it a little bit neater. I have wire 3 here, we'll connect there, we'll connect here. The nice part is that we can use a few more wires than what we have. So now that's our one pathway as we've seen, but now obviously we can have another going down. We have one here, we'll connect there, we'll connect there. I'll just do this one here. I'll add a few extra wires just so it looks a little less messy for you guys. And then we'll connect here. So now you see that these electrons actually have multiple pathways that they are now going down. But what I want you to notice is I'm actually going to, so we see where these lines are here for the brightness level. So we see where they are, that the light doesn't actually get any brighter. And that's the difference between a parallel circuit versus a series circuit, is that the overall brightness of the light bulb does not change just because there are two light bulbs that need to be powered. The benefit of a parallel circuit is you get the same full level of brightness as if only one light bulb was connected, but you actually have two light bulbs, which is the benefit of that. So now another benefit of having a parallel circuit versus a series circuit, to give you guys a little bit of insight, series circuits, if you ask your parents, are what Christmas lights are. And if they've ever had a series circuit Christmas lights, the big problem with those is that when one light bulb burns out anywhere on the Christmas lights, none of the light bulbs work. And that's because they are a series circuit. So there's only one pathway for those electrons to flow down. And if one break in the circuit happens, so one light bulb is burnt out, that means none of them will work, which is a big problem because you have to go and test every single light bulb to see which one is not working. Whereas for a parallel circuit like this, if I add in a, oh, no, I'm not going to trash that. If I make a cut here and instead I add a switch here, so I connect here and then I just reconnect it here. So this one is still being powered even though this circuit is not complete because there's an additional pathway. But if I connect it, then they all continue to work. So I can have one light bulb on and not the other one. If I want the other one on, I just have to complete the circuit and it will allow it to happen. And that's the benefit of a parallel circuit, is that even if one light bulb were to burn out, so if I disconnect here, this other light bulb is still running because it has more than one pathway for it to make its way back to this main battery source. And that's all that you guys will have to do. So you have, again, you're building these circuits on this website. You have this worksheet, either one with the switch or without, that you guys will work through with your drawing and explaining what's happening. And then you have your take-home assessment, you have your take-home worksheet, just so you can identify these two different ones and explain the difference to me. The main thing I'm really looking for is you to be able to explain the difference. Not necessarily identifying, but being able to explain the difference. If you guys need any help, I don't expect you guys to be working on this over the weekend, but come next week, if you guys have any questions about this, feel free to reach out to me and let me know. I am here to help. You guys have a great day. See you later.